Hello friends, welcome to the Paradox classes. I am particularly from the mechanical engineering disciplines, so I am going to cover all the mechanical engineering subjects from basic to competitive exam level. I can say it will helpful to you from diploma level to gate level examination. So stay tuned, and this is going to be my first video in particular subject thermodynamics. So let's start from introduction of thermodynamics, and I'm going to cover all the basics of thermodynamics in this particular lecture. So let's start. Okay. First, for every subject we should know the meaning of that particular subject. So let's see what is thermodynamics. Thermo means heat and dynamics means motion. That is motion which is caused due to the force. And this force means action of force on moving body is known as a work. So we can say that the thermodynamics is nothing but it is the branch of science in which we convert the heat into work. Means a non-organized form of energy into organized form of energy. That is heat, which is a non-organized form energy, and work, that is organized form of energy. So there are lots of examples of these you can see every day in day-to-day life, like vehicles, which converts the fuel energy, which is a heat energy, into the work, so we can go from one place to another place. And you can say fan, or you can take example of tube light, and there are lots of examples like that. When you on the switch and the bulb blow, that is also electrical energy, which is a heat energy. And bulb blow, that is the work done on the room, that is the organized form. And fan also the same example. Now let's move further. The branch of science which deals with the heat and work interaction and its effect on the properties of the system, which is thermodynamics. Thermodynamics talks about the properties. A property which distinguished thermodynamics from other science, that is a temperature. And we know that every body has a certain amount of temperature. Every body in the universe have some temperature. Absolute zero temperature we didn't found yet. It is not possible actually. So we can say thermodynamics we can apply everywhere, because each and every body in the universe have certain amount of temperature. So this is what the thermodynamics is all about, and this is how you can define the thermodynamics. And further we can see that the thermodynamics is actually based on certain laws. For example, laws of conservation of energy, law of conservation of mass, and etc. etc. There are many laws or many things we are going to see in this on which thermodynamics is based. And what is the law? Actually, lots of students are there who don't know the meaning of laws. Actually, laws are statements which are universally truth but cannot be proved mathematically. So remember this, the laws are statements which are universally truth but cannot be proven mathematically. Okay. And thermodynamics, most importantly, it talks about the things which are not possible. For example, according to second law of thermodynamics, no heat engine can give 100% efficiency. So there are lots of things we can say that thermodynamics tells that are not possible at all. So the subject has many importance on its own. And yeah, after this we can say how we are going to study the thermodynamics. basically there are two approaches to study the thermodynamics. First is a microscopic approach, MI, that is what we call as a statistical thermodynamics, and macroscopic approach, that is MA, that is classical thermodynamics. And we can define these both of approaches in short term that in microscopic approach, MI, each and individual molecules are considered for analysis and to study behavior of the system, where as in case of a macroscopic approach, the attention is focused only in certain quantity of matter without giving the event occurring at molecular level. Okay, so in micro we are going to study individual molecules. Here the attention is focused on a certain quantity of matter. So in our engineering branch we only study the macroscopic point of view, that is classical thermodynamics. We only study that in particular mechanical engineering thermodynamics subject. So in classical thermodynamics what we are going to do, that we try to establish the relationship between the measurable and non-measurable properties. And some students who want to know that what is microscopic approach. So microscopic approach is generally used where low density medium like in the universe or that kind of places, like in the space. So that is really a deep study, and for that we have to gain knowledge about the macroscopic approach. So in our thermodynamics we only contain classical thermodynamics. Okay, so what are the measurable properties and what are the non-measurable properties? Measurable properties are pressure, temperature, volume, etc. We know that we can easily measure those properties, whereas non-measurable properties, entropy, enthalpy, internal energy, etc., that we are going to define in thermodynamics, and how we can find out those properties, various kind of charts which will be helpful for us to find out that things we will see in further. Okay, so let's start with our, after introduction, our first topic in thermodynamics is thermodynamic system. Simply we can define it by quantity of matter or a region in a space where our attention is focused for analysis is called as a thermodynamic system. Quantity of matter, a particular thing that we can classify further in closed system. Quantity of matter means it is a control mass. So we can put two more classifications. The quantity of matter is in the closed system, that is control mass, where a region in a space, that is a case of an open system, which is a control volume. We will further see deep in closed system and open system after this. And everything external to the system, the quantity of matter or a region of a space, that is control mass or a control volume, external to that everything is considered as a surroundings, and the line or anything that is separating the system and surrounding is simply known as a boundary. Yeah, you can see from this figure, system, surroundings and system boundary, which is separating the system and surroundings, like a cricket ground. The cricket ground, the players playing the cricket inside the system, everything outside that ground, the boundary separating that is surrounding. Okay, so in thermodynamics, where we are doing our analysis, that region, that matter is known as a system, and everything outside that is a surrounding. Okay, and the main thing that separating that both